Hello everyone. Today I'm going to be showing you how to make a Windows bitmap file from a piece of text, a text file. We're going to be making the file using the hexadecimal number system, and I'll show you actually what we're going to be making. We're going to be making a 3 pixel by 3 pixel bitmap file like this one. You can do this with any size pixel. This is one that the instructor for the class that I'm taking and doing this assignment for did. We're going to be making something like this. We won't do the same colors. This was something that I did to kind of test and make sure I knew what I'm doing. But yeah, we're going to make something along those lines, and like I said, you can do this with any sized you can do 100 pixels by 100 pixels. You just be typing a lot more number values in. So I'm going to show you how to do the 2 headers, and there's 2 headers that you put before you start typing any color data into the bitmap file. You have to do 2 headers, the file header and then the dib header, and I'll show you how to do those, and then I'll show you how to enter all the bitmap data. And I'm also going to show you how to calculate the padding for how much, so I'll explain it later, but I'm going to show you how to calculate the padding. So the first thing you do when you create a bitmap file is you type 42 or D. Those are always the first 2 bits in a hexadecimal bitmap file, and that is telling whatever's reading the file, hey, this is a bitmap file, and you always have to type that. The next 4 bytes are going to be the size of the actual bitmap file in bytes. Alright, so for our purposes, we're going to type 5 and then A, because this is a 90 byte file when we're done with that. We know that there's 14 bytes in the bitmap file header, and there's 40 bytes in the dib header, and then the remaining bytes are all the padding and the image bytes, the color bytes. Alright, so it's actually, after you do the first 2, the next 4 are going to tell you how big the file is. But because we're working with such a small file and there's only 90 bytes, the next 3 bytes are just going to be 0. So 0, 0, 0, 0, 0, 0. Alright? And I should mention that the app that I'm using to write this all up is HexFiend. You can also use the hex editor in Sublime Text if you have Sublime Text and you like it. It's just the Sublime Text hex editor makes everything a little bit more complicated, and I wanted to keep this simple. Alright, so after you have those 4 bytes, these 4 bytes of color data, or size data, excuse me, how big the file is going to be, the next 4 bytes are going to be just, or the next 4 bytes are just going to be 0. So the reason they're 0 is because depending on what application creates the image, sometimes they'll toss extra information in. But because we're just typing this image, we're going to not use those 4 bytes for anything. So again, 0, 0, 0, 0, 0, 0, 0, 0, and there we go. The next 4 bytes are going to be the offset. When we're typing this whole file, there's going to be this header, and then there's going to be the dib header, and the number that we type next is going to tell the file where the actual color data is found. And for our purposes, we're going to type in 36 and then 0, 0, 0, 0, 0, 0, and then we go and we start the dib header. So I should mention, if we go to Wikipedia real quick, sorry, my keyboard is so loud. If we go to Wikipedia here, there's a really helpful guide that tells you exactly what all the bytes in the bitmap file header are. And then there's a couple different dib headers that you can do. There's this one for OS 2, which is a really old Windows operating system and stuff like that. We're not going to use that. We're not going to use this one right here. This one, that didn't go as planned, that highlighting. We're going to use this information right here, the one that's titled Windows Bitmap info header, and that's the format that we're following for this. So it's a 40 byte header. So now we're actually starting the file. So we're going to type, the first 4 bits are the size of the header. So we're going to type 28 00 00 00 00, and those 4 bytes right there are the size of the header. And now you're going to type the width of the image that you're going to make in pixels. And like I said, we're going to be making a 3x3 just for brevity's sake here. So 03 00 00 00 00, and those 4 bytes are the width of the image. So now we're going to do exactly the same thing because it's a 3x3, but for the height of the image. So 03 00 00 00 00. And now we have the dimensions of our image that we're going to create all set up here. The next thing that we input is the color plane. The color plane is just always 1, and it has something to do with the way the color values are read by the file, but it's always 1, so just 0100. The next thing that we're going to input is the number of bits per pixel, which is the color depth of the image, and you can have 1-bit, 4-bit, 8-bit, 16-bit, 24-bit, and 32-bit. 32-bit is transparency, so 24-bit color is the most color that you can do with, having 255, the largest 1-byte hexadecimal number, as one color value, and you have 3 bytes per color. For our purposes, we're not going to do that. We're just going to start with 24-bit color. We're not going to worry about transparency. So we're going to type 18, because that's a hexadecimal value for 24, and then we're going to type 00. And then the next 4 are going to be just 0. It's the compression for the image, and that's not really important for our purposes. So 00 00 00 00 00, and there we go. And then the next 4 are going to be 1 0 and then 3 sets of 0. That's the image size. This is the size of the raw bitmap data. 16 is what it translates to in hexadecimal. So we're going to type 10 00 00 00 00. And then the next information that we're going to type in is going to be the horizontal resolution of the image. This is going to be like if you're going to print stuff. I don't think, I'm computer science. I'm not like a design person. I don't think anyone's going to want to print this image here. But if you did, this is the information that the printers would need in the file, and it's going to tell you the print resolution. We're going to type in 1313 0B, and then again we're going to put 2 bytes of 0 because that's a 4-byte value there, and we're going to do the exact same thing again, 13 0B, and then 2 bytes of 0, and then the next 8 bytes are all going to be 0, and that's the number of colors in the palette. And that's for like if you're editing this in an editor, but we're not going to use any of that. So we're going to just type 00 00 00 00, and that's the first 4 bytes. And then the second 4 bytes are important colors, which there are none in this photo, so just 00 00 00 00 00. And congratulations, we have finished the div header and the main header. So these 54 bytes right here are all the header. This is no color data. If we were to save this right now as a BMP file, I guess I should point that out. So file save as video image, and we're .bmp, and we're going to save it to the desktop. And if you try to open this now, it can't be opened, and that's because it's damaged, because it's not a complete file. We're telling it when we say here that it's a 90-byte file, but it's only 54 bytes right now. Now we get to start doing the fun stuff. We get to start designing our image. We've done our bitmap header right here, the first 14 bytes, and then the next 40 bytes are our div header. So we're ready to input color value, but before I go and I talk about that, let's just talk about this number for a minute. This converts to 90 in decimal, in hexadecimal it's 5A, and it's the third byte of information in our bitmap file. And that tells the computer, or whatever is reading the file, how big in bytes the file is. And let's just talk about that number for a second. So the first 54 bytes, we're over in this Sublime Text now, the first 54 bytes, the first 14 bytes are the bitmap header, and then the next 40 are the div header. Okay, and that comes out to be 54 bytes. So how did we get to 90 bytes? Because if you add 3 bytes per color up, and there's 9 colors, 3 times 9 is just 27, and 27 plus 54, you see, is just 81. Where did we get those extra 9 bytes from? Well, for each row of color data, so there's 3 pixels per row, and for each pixel there's 3 bytes. So there's 9 bytes per row of information. But the way bitmap works is you have to have a multiple of 4 per row. So what we do is add something called padding, and you can be padding value can be anything you want it to be, and it just goes on at the end of the row. So what we're gonna do is we have to calculate, there's 3 rows, and each one has 9 bytes, and if they all have to be a multiple of 12 or a multiple of 4, the closest value is 12. So there's an extra 3 bytes per row, and so there's an extra 9 bytes in total. So if we do 54 plus 27, that's 81, plus 9, and then we get our 90, which is where that number comes from. And as we input the color value, I will show you where the padding goes. So there we go. That's what we're going to be typing in. We already have the 54 bits of bitmap header. So now we're just going to go ahead and start typing in the color data. Now, how does the color data work? In a standard RGB color, there's R, G, and B, which just stands for red, green, and blue. But the order we input colors here is actually blue, green, and then red, like that. So the first value is blue, the second one is green, and the third one is red. Now, where does the color start? You would think, okay, maybe it starts here, but unfortunately that's incorrect. If you're looking at right here, this 1 by 1 pixel, you think, okay, that's probably the first one that gets filled in, but that's wrong. The first color that gets filled in is this square right here, where this blue square right here, that's the first one that gets filled in. And right now we're going to fill in the bottom left square. So let's make the bottom left square yellow. To make yellow in hexadecimal 3-bit color values, all you have to do is 00 FF FF, and that's going to give you full red, full green, and 0 blue. And when you're adding colors together, you know, additive colors in physics, when they add together, they make those colors. You can also make magenta and cyan and every other color in the world. It's not like mixing paint, that's subtractive colors. That's the opposite, essentially, but I'm not going to get into that. So that's our first byte of color information. And let's put in another 2. Let's make the second one blue, so FF0000. So that's the second pixel. So in this image, this pixel is going to be blue right here, okay? And then the third pixel, we're going to make that, let's make it green, so 00FF00. All right, but now we've got our 9 bytes. That's our first row. But the 9 needs to be a multiple of 12, and 9 isn't a multiple of 12. So we're going to put in some padding. And padding can be anything you want it to be, as long as it's the right number, like the right number of bytes. So just for making it stand out and making it clear here, we're going to make our padding value B. So there's going to be 3 bytes, so BB, BB, BB. Now let me make it clear. The padding can be anything. It doesn't matter what the padding is. You can hide secret messages in it, or you can just make it 0, or you can make it anything else. It doesn't really matter, okay? So now that I'm making it BB so that we know that that's padding and we can differentiate between it. All right, so that's our first row. These 4 numbers right here. So that's 12 bytes, right? You can see 12 bytes right there where my mouse is. So now that we've got the 12 bytes, let's continue. So now that we've done our padding, I'm gonna just fast forward through typing in the next color values. It's exactly the same as the first, and I'll stop when we get to the padding, all right? Now we're gonna put the padding in, okay? So we're gonna say it's the same as before, 3 bytes of padding to make an even 12 per row, okay? So now we can start our third and final row. All right, so we've inputted our last row of color data, and we're still short 3 bytes. Remember I said that we needed to have a total of 90 bytes here, and we told the program we needed to have 90 bytes, but we're 3 short. And that's because you have to add padding at the last row too. So without further ado, let's put those 3 in. And now we're 90 bytes. We can see that right here at the bottom of the HexFiend app. It tells us we have 90 bytes. So let's go ahead and save this. We're going to save it as videoimage.bmp like that. We're going to save it to the desktop so we can see it. And it pops up, open it, and zoom in because it's only 3 pixels by 3 pixels. But you can see, looking at the image, we told it that the first byte was going to be yellow right here, and it's yellow. Second byte is blue right here, and the second byte is blue. Okay. So there's our image, and that's how you make a image just typing in stuff in Bitmap. And before people in my hallway start making too much more noise, I'm going to sign off. Thank you for watching my tutorial, and I hope you enjoyed it. Adios.